In this video, we're going to talk about how to name ions. So atoms are electrically neutral, and it's because they have the same number of positively charged protons and negatively charged electrons. Ions, you might remember, are atoms or groups of atoms that have a charge. They have a positive or a negative charge. And it's because they have different numbers of protons and electrons. Only electrons can move, and ions are made by the gaining or losing of electrons. So the charges an ion has are due to the extra electrons it either gained or the electrons that it lost. There's two types of ions. An anion is a negative ion. So the way we're going to remember this is how you spell anion, A-N-I-O-N. A negative ion is an anion. So an anion has gained electrons. Remember, electrons are negative. So if you gain a negative electrons, you become a negative ion. And nonmetals are the types of elements that become anions. They gain those electrons because remember they have that strong electronegativity. So an anion is written, when you write an anion, you write the charge written as a superscript in the upper right hand side of the element. So this would be a fluorine atom, but when a fluorine atom gains an electron, it becomes a 1 minus charge. And the new ending for the name, it's no longer a fluorine atom, it is a fluoride ion. So anions always end in "ide." So this is oxygen. Oxygen is going to gain 2 electrons. So when it gains 2 negative electrons, it gets the charge of 2 minus. So it's no longer oxygen, again it is oxide. You change the ending to "ide." A cation is a positive ion. So the way you're going to remember this is the T, not so much in this font, but the T in cation kind of looks like a plus sign. And they're formed by losing electrons. If you lose a negative electron, the positive protons now outnumber the negative electrons, and you have a net positive charge. And metals are the only elements that form cations. They lose electrons because they have that weak electronegativity and they give their electrons away. So here's a metal like potassium. It is a potassium atom, but if it loses 1 electron, it obtains a 1 plus charge. So it's no longer a potassium atom at this point. To name a cation, it's very simple. All you need to do is add the word ion. So it's not a potassium atom, it's a potassium ion when it loses 1 electron. So a calcium atom loses 2 electrons and it gets a 2 plus charge. So it's not a calcium atom when that happens anymore, it is a calcium ion. So you should be able to predict the ionic charges for elements based on their position on the periodic table. Everything in group 1 has 1 valence electron, and it's going to lose that valence electron to become stable like a noble gas configuration. So all of these here in group 1 will become 1 plus ions. Everything in group 2 has 2 valence electrons, and they will lose those 2 valence electrons to become 2 plus ions, like beryllium 2 plus, magnesium ion, calcium ion, strontium ion, barium ion. If we skip over to group 13, they all have 3 valence electrons, and remember they're still metals or metalloids, or no, they're all metals. Everything in group 13 is a metal. So metals still lose electrons because of that weak electronegativity. So they're going to all form 3 plus ions. Group 14, so we have a choice here. Everything is trying to be like a noble gas. These took the easiest route. They lost 1 or 2 or 3. That was easier than gaining 7 or 6 or 5. But now we have a choice. I could lose 1, 2, 3, 4 to become like helium if I was carbon, or I could gain 1, 2, 3, 4. Which one is it? The answer is neither. Group 14 elements rarely form ions. They tend to share electrons and form covalent bonds. Group 15 are now strongly in the non-metal zone, so they're going to gain electrons because they have that strong electronegativity. Nitrogen, phosphorus, and arsenic are all going to gain 3 electrons and become 3 minus anions. We would call them nitride and phosphide and arsenide. Group 16 are 2 away from the noble gas, so they're going to gain 1, 2 electrons. They'll all form 2 minus ions like oxide, sulfide, and selenide. Group 17 are 1 away from the noble gases, so they're going to gain 1 electron to form 1 minus ions like fluoride, chloride, bromide, and iodide. In group 18, oops, went a little ahead there. Group 18 are stable noble gases, so they don't form ions. They have complete outer shells, 2 in helium's case, 8 in everybody else's case. So they're stable, and they're not going to give electrons away, and they're not going to take any more electrons because they don't have any room, so they do not form ions. So you notice we skipped the B metals here, the transition metals in the middle here. So the group B elements tend to have more than one possible oxidation state, which means they can form more than one type of ion. So let's take iron, for example. Now you can't see it on my periodic table, but if you look at your periodic table, and in the upper right-hand corner for every element, you'll see some numbers. And iron in particular has 2 in the upper right-hand corner. It has a 2 plus and a 3 plus. That means it can form a 2 plus ion or a 3 plus ion. So if we just said the word iron ion, you wouldn't know which one I was talking about because there's 2 versions of an iron ion. So in these cases, the way we name them is with Roman numerals. So this would be iron Roman numeral 2. The Roman numeral stands for the charge, 2 plus. And this one would be iron 3. So note the use of the Roman numerals shows the charges. So this actually makes your life easier. If you have a Roman numeral, you automatically know what charge it is. If they just give you an element that is in the transition metal zone here, you have to look to see what kind of charges it has. More on that later. So there's 2 methods to clarify when there's more than one charge that's possible. There's the classical method that uses root words with suffixes. So the root words you'd have to memorize, and the suffixes you have to memorize what they mean, and it's pretty complicated. Most people don't use that method anymore. The New York State Regents uses what's called the stock system. It uses the Roman numerals you just saw in parentheses that indicate the numerical value of its charge. So we'll be using that system. If the charge is always the same, like a group A element, all you have to do is write the name of the metal and then add the word ion. Transition metals that have more than one type of charge, you need to indicate the charge as a Roman numeral in parentheses after the name of the metal. Also, there are some post-transition elements that can have more than one possible charge, and you just need to memorize them. There's 2 of them. There's tin, element 50, and there's 2 oxidation states for tin. It is 2 plus and 4 plus, so it would be tin 2 and tin 4. And then also lead. Lead can also be 2 plus or 4 plus, so it would be named lead 2 or lead 4. So there's also some group B elements that have only one possible oxidation state. So if you look in the upper right-hand corners, you'll be able to find some of these. Elements like silver can only have a 1 plus. So we wouldn't say silver 1 ion because there's no other type of silver ion. So you would just say silver ion. Zinc can only be 2 plus, so that would just be called zinc ion rather than zinc 2. And cadmium, they're all kind of lumped together in the same area here. Cadmium can only be 2 plus, so it would be a cadmium ion. So note, we did not use Roman numerals. We only use them when there is more than one possible type of ion it can be. All right, so let's practice some of these. I want you to pause the video and in your notebooks, write these down and see if you can name these correctly based on what you just learned. Okay, let's see how you did. So the first one here is sodium, and it's in the group A elements, so it's a group 1 metal, so we would just call it sodium ion. Next we have calcium ion, and then we have aluminum ion. So the next element, iron, is in the transition metals. So you need to look when you get to a metal that is a transition metal and look in the upper right hand corner and see if it has more than one possible oxidation state. And iron does. It can be +3 or +2. So when we name it, we need to use the Roman numeral. So Fe is iron and it is a 3 plus charge, which is why I wrote iron Roman numeral 3 ion. Okay, I have the other version of iron next, so this would be iron 2 ion. In our next question here is lead. Remember, lead is one of those two post-transition metals that has more than one oxidation state. So even though it's not a transition metal, you need to use a Roman numeral for elements like tin and lead. And this one is lead. So this would be lead 2 ion. And then the last one, lithium. Lithium is a group A element. It's not a transition metal, so no Roman numerals necessary. We would just call this lithium ion. Okay, we also should be able to go from the name to the symbol. So again, pause this video and give these a try. And when you're ready, unpause it and see how you did. Okay, let's see how we did. Potassium ion. So potassium is element K, and it's in group 1, so it gets a +1 charge. Now you can write 1 plus, or you can just write plus. You can leave out the 1 if you'd like. Magnesium is Mg, and it's in group 2, so we'd write Mg 2 plus because it's going to lose those 2 valence electrons. Everything in group 2 will behave the same way. Okay, next we have an element with a Roman numeral. Now, like I said before, this makes your life easy. You know exactly what the charge is. It's given to you in the Roman numeral. So your only challenge here is to figure out the symbol for copper. And if you don't know, you can look it up on table S. It is Cu, and copper 2 ion, of course, its charge is 2 plus. Next, we have chromium 4 ion. So chromium is Cr, Roman numeral IV. If you don't know your Roman numerals, please study up. IV means 4, so it is a metal, so it's of course 4 plus. Next we have barium ion. Barium is Ba, and it's in group 2, so it gets a 2 plus. And last we have mercury 2 ion. So mercury is a hard one to find on the table. If you need help, look at table S again. It is Hg. And the Roman numeral 2 tells us it is a 2 plus charge. Next, let's look at how to name anions, the other type of ions, the negative ions. Anions are always the same charge. Even if you look in the upper right-hand corner, you'll see that there's multiple oxidation states. Those are for something else. We'll talk about those later in the course. But anions always have the same charge. And you can get that charge just based on its position on the table. And then you just need to change the monoatomic element's ending to "ide," and you've named the anion. So a F1 minus is a fluorine atom is going to lose 1 electron and become a fluoride ion. So let's do some practice. Pause the video, write these down in your notebook, and try to name these. When you're ready, unpause it and see how you did. Okay, here we go. Cl is chlorine, so it gains 1 electron to become chloride ion. N, of course, is nitrogen. It's going to gain 3 electrons and become nitride. Br is bromine. It's going to gain 1 electron and become bromide. O is oxygen. We'll change that ending to oxide when it gains 2 electrons. And the last one is gallium, and it is not going to be galide. If you said galide, you fell for the trap. Look at the charge, 3 plus. That means it's a metal. Metals don't gain electrons and become negative anions. They lose electrons and become positive cations. So the charge here tells me that it's a metal. It's a cation. So I just need to add the word ion at the ending. So hopefully you didn't fall for the trick there. Okay, we also need to go the other direction. So if I give you the names, you should be able to write the symbols. Go ahead and pause the video and give these a try. And when you're ready, unpause. Okay, so the first one's sulfide. That has its root in sulfur, so I'd write the element S. Sulfur is in group 16, so it would have to gain 2 electrons, so it would be a S2 minus charge. Iodide comes from iodine, so that's I, and it's in group 17, so that would just have to gain 1 electron to be like a noble gas, so it would be I with a 1 minus, or just a minus. Phosphide comes from phosphorus. It's in group 15, so it would need to gain 3 electrons, so it would be P3 minus. And then strontium ion. If you find strontium ion on the periodic table, hopefully you recognize that this is a metal. It's in group 2, I believe. So strontium, yes, will lose 2 electrons. It's not going to gain electrons like the others. So I tried to trick you again. Hopefully you didn't fall for it. So next I want to talk about polyatomic ions. These are groups of atoms that stay together and have an overall charge in one name. You should recognize a polyatomic ion by its ending. They usually end in ate or ite. Now there's a couple of exceptions, but most of them end in ate or ite. So their formulas and charges can be found on table E. So this is table E. It has a list of all the formulas of the polyatomic ions that will be on the reagents, and it has their names. And if you look at the names, the first three don't follow that 8 or ite, but after that we have 8. The next example, cyanide, that's another weird one. That's one that doesn't follow. But then the rest of them are 8s or ites. On this side, all 8s or ites. We have another one, peroxide. This is pretty rare, but um, we won't see this too much. Hydroxide is another exception, but the rest are all 8s or ites. Now again, you don't need to memorize these, you need to recognize them. So if you see these elements together, they're usually in parentheses if they're written in a formula. If they're written in words, you should recognize 8s or ites are not something that's typically on the periodic table. Now there are some that end in "ide," which might make them sound like a typical anion, but they're not. So like if you had cyanide, there's no element cyan. Um, you might get confused with carbon, but this is not an ion of carbon. Carbon doesn't form ions. So again, you just need to learn to recognize this, and this is going to come with practice, but you need to be very ready to use table E. You're going to use it a lot in this chapter and other chapters that come. So let's wrap up here. Ions are atoms or groups of atoms that have a charge, and that charge is due to a gain or loss of electrons. You should be able to predict the charges of group A elements based on their position on the periodic table. When naming group A cations, it's very easy. All you need to do is write the word ion after the element. When naming group B cations that have more than one oxidation state, you need to add a Roman numeral for their charge. And when you name anions, all you have to do is change the suffix to "ide" and then add the word ion. So that's how you name ions. I hope that made sense. And if you have any questions, please let me know.